Hi all, this is day 96 of my GATE CS prep. So why I'm recording this, I am left with 12 lecture of data structure. Basically they have done live and now I'm pending with 12 lectures. So I've just done with my first, there were like total 13, but now I am done with the first lecture of the data structure with my handwritten notes that I made. It was of 2 hours, but I done in 3.5 hours. So I wanted to record this playlist so that I can quickly revise it also, and it would be like just overview revision kind of thing for data structure. 12 are remaining, so I'll be doing like as soon as I complete the lecture with notes. So this comes under asymptotic notation, and the topic is design and analysis of algorithms. So basically, first is what is algorithm? It's a sequence of finite step designed to solve some specific problems. It takes an input, processes it, and then gives an output. So meaning of processes is perform some operation on an input. You can see in the diagram it gives input, takes input, performs some operation, and then gives output. So there is example of like multiply the two given integers a and b and then print the values. There would be steps like to take two given integer a and b, multiply it and store the result in some variable called c and then print it. Then there are characteristics of algorithm, like it should always terminate after some finite amount of time. It should be deterministic, means the specific algorithm should always produce some output for same output for same input. You can see the diagram I have drawn is not correct. If I'm giving I1, it should produce O1 output only, not O2. So this is not the correct thing. After this, like there are some real world problems where algorithm used, like problem are Google search, an algorithm used as searching algorithm, Google map shortest path algorithm, Amazon search searching algorithm, Amazon sort sorting algorithm. So these are some real world problems for which we use algorithm. Analysis of algorithm is process of finding amount of time and storage space needed to execute them. That is the analysis of algorithm. And why we analyze the algorithm: to choose best possible algorithm for a given problem in terms of time space it needed for execution. So there would be more than one algorithm present, so we need to choose the best based on the time, which takes less time and less space. So space is not the concern, but because we don't care about space, we only need the faster result. So time would be the important factor out of these two, and based on that we'll choose the algorithm. And like gate point of view, running time is the important, not the space. And what is analysis of running time of an algorithm is basically we calculate the running time of an algorithm by calculating the total number of times each statement gets executed. So there is this problem or example you can see we have here, like to print the sum the all the values of array and print the result. This is pseudo code, and logic I have explained in like detail what it is. Basically it's doing sum of all the values present in array and storing it in some variable, and when the index gets over we print the last result which is present in some variable. I have drawn the diagram also, you can see. So these are the complete stepwise execution I have done for each index, and the final value is S29, so that would print. Now this logic we need to convert into pseudo code. Like this is all the detailed example of pseudo code I have written. I have created some array, name function and write logic in it. So algorithm takes input, so we need to give the size of array which is n. I have given in pseudo code. Pseudocode, that logic it's syntax, so we don't care about syntax because it's a pseudocode. And so 0 and 8 need to traverse from index 0 to 4 and all values add in s variable. Execute the loop from index 0 to n-1 cause size is n. So for example, if we have array of size 5, we would traverse from 0 to 4. That's how 0 to n-1 will run. For I equal to 0, come in, add index 0 in s, then increase I by 1, and that's how arrow will move forward till last index. So that's a algorithm or logic before this pseudo code. And then running time, you can see like for each statement how many times it's executed, we need to find that. So first is statement 1, which is sum equal to 0. It's just assigning the 0 and sum, so it would execute it one time only. So it's 1 into c1. C1 is cost. That like because cost is some statement would take some time to execute it, but since cost is machine dependent, we are ignoring here because s1 might take different type on different time on different machines, so no need to take c1, we can ignore it. Then there is for loop, and for that I have calculated the running time also, because for n values it would execute from 1 to n minus 1, so total time would be n time. That's how we calculate the running time, and at the end we total of all the thing. So there is again another problem to print the value from 0 0 to n minus 1 and n minus 1 times, and for that also we need to write pseudocode logic and calculate running time also. I have done that here. Like, it's very detailed explanation, but you might get the idea of it. So now after doing 2 problem on calculating running time for each statement, there might be problem because there are codes, right? In real time there would be 1,000 lines of code, so we cannot calculate running time for each line. So, and it would be very tedious to go through each statement and count it. So solution for is we need to select the most dominating term and avoid less dominating term and constant. So the running time we calculated for 2 problem were 2n plus 3, and here most dominating term is n, so we have ignored the 2 and 3 constants, and same here, n square plus n square is most dominating term. So there might be question why we are selecting most dominating term, why it works. So because growth rate of running time mostly depends on the most dominating term, and remaining term and constant becomes insignificant. Growth rate is as we increase value of n, which is size of n input or length of the input. At what speed running time will grow is the growth rate. So here is proof also why we are selecting n square as most dominating term, and here we have taken values as 10, 100,000, and then after we take the percentage, then the gap is very less, so that's why we take most dominating term. So here again, lastly, why we avoid 2, which is constant in 2n square, because growth rate of running time does not depend on constant. And here is proof of also, like if we say n is 10 and then 500 in 5n square we put, it's taking, you can see n square is like 5 does not contribute anything, so a1 is best cause running time less, and this is greater than, if we take like lakh in terms of n square, then this is getting very bigger value. So if constant would be contributing, then 100 into n, if I put 100 into n, which is lakh, it might have been the bigger value, but that's not the case. So GR does not depend on the constant. So this was the first lecture of data structure, which is design and analysis of algorithm. So I would be covering the more lecture as I complete them. So that's all. Thank you for watching.